about a negative 9? What's the y value? Positive 4. Okay, so my new shape, same shape as my old shape, but everything has been shifted 5 units over to the left. So what I'll do is I'll give you a graph. I'll tell you to now graph something else. Or looking at the graph, can you tell me the new formula? Like work both ways. Here's a formula, graph it. Or here's a graph, what's the formula? Okay? So this is only part of the story though. This is just a shift. There's other transformations we can make, but if we don't understand the shift, then we shouldn't even go into the others. Is that better? Okay. So here's how you accomplish these shifts in the formula. That's what you do. The next transformation we want to look at is flipping the graph over the x-axis. The fancy word for flipping is, a better word for flipping is reflection. And we're just going to do reflections in the x-axis. So we're not going to do y-axis reflections. So how do you accomplish a reflection across the x-axis? You do that by taking your function and putting a negative, basically multiplying it by -1. That's how you accomplish a flip across the x-axis. So here's all our functions. X squared, absolute value of x, root x, and x cubed. If I want to take these and flip them over the x-axis, I multiply them by -1. So I have negative x squared. That's not negative x quantity, that's -1 times x squared. Or I take the absolute value and I put a negative in front of it. Or I take the square root and I put a negative in front of it. Or I take this x cubed and I put a negative in front of it. All of these would accomplish the goal of flipping these graphs over the x-axis. Y equals x squared flipped over the x-axis looks like that. Y equals absolute value of x flipped over the x-axis looks like that. Y equals negative the square root of x is a flip over the x-axis on the square root of x. And then finally the last one, y equals x cubed with a negative on it. As I flip over the x-axis there, so instead of being, this one's difficult to draw. Looks like that. So that's a flip, a reflection across the x-axis. Basically, every y value which was negative is now positive. Every y value which was positive is now negative because we have multiplied the function by a -1. That accomplishes the goal of changing signs on your y values, reflecting it across the x-axis. We're not going to worry about reflecting across the y-axis. Question, yes?
For the graph on the bottom right, don't you need a negative square root of x on the after that?
Thank you. Okay, so we can combine this together with what we've already done, our horizontal and vertical shifts. If we do combine them, though, we want to make sure that this happens first. If there's shifts and reflections at the same time, it's kind of like an order of operations. The reflection has to happen first. So if I want to take y equals absolute value of x and do 3 things to it, I want to reflect it about the y-axis, do some sort of a shift to it, both horizontally and vertically. This is a transformation on absolute value of x. We're going to list what things are being done to it, and then we're going to draw the graph. So describe the transformation. Would be what the question says. And then draw the graph. It's just a combination of everything we've done so far. The graph needs to be reflected or flipped over the x-axis. It's the first thing we should do. And then it needs to be shifted. There's 2 kinds of shifts going on here. There's a vertical shift and a horizontal shift. We said that if we take and subtract 3 at the end, that's a downward shift. And so we need to shift down 3 units. We said that, well, if we're in there with the x and we take away something, we said that that's a shift to the right when it's in there with the x. And so we need to shift to the right 6 units. All 3 of these things are done at the same time. Well, not at the same time, but all 3 of these are done to this, I don't know if you want to call it a parent graph or whatever. We start with y equals absolute value of x. We do these 3 transformations to it, and this is what we end up with. So let's draw the graph. Normally, that's what it looks like. We need to reflect it over the x-axis, shift it down 3 units, shift it right 3 units. I'm sorry, right 6. Sorry about that. So we flip it. You don't have to do each individual.